This is example 8 from chapter 4, all about moments. So what we are going to do is we are looking at this uniform rod from P to Q, and it's hinged at this point P here and held in equilibrium. Now remember, equilibrium means that the moments clockwise is equal to the moments anti-clockwise. And it's held there at an angle 50 degrees to the horizontal with this force F at the end there, force F, which is perpendicular to the rod. Given that the rod has a length 3 meters, so let's add that on, 3 meters is the length of the rod, and a mass of 8 kilograms, find the value of F. Now it's quite good, they've already put that weight downwards, so we know the mass was 8, so therefore the weight is 8g, and that's going to be 1.5 meters down there because it's acting in the middle of the rod because it's uniform. So we know that the rod is in equilibrium, so that means that the moments clockwise are equal to the moments anti-clockwise. And we're going to be taking moments about that point P. So taking moments about the point P. Well, if I think anything that's going clockwise, I'm at the point P, anything that's trying to go clockwise is this weight here. That is going to be causing my clockwise moment. So the force is 8g, and I need to multiply it by the perpendicular distance to that force. Well, we know that the distance along the rod is 1.5 meters, but the actual distance to the perpendicular distance won't be 1.5. So if I just draw that little triangle we've got a bit further on, so you've got, this is the 1.5 meters, the force is acting down here. And we want to know the perpendicular distance, so that distance there, to get to the force. Well, this angle here is 50 degrees, so that distance will be 1.5 cos 50. So my force was 8g, and I'm multiplying by 1.5 cos 50, the perpendicular distance. So that's the clockwise moment, and it's equal to the anti-clockwise moment. And so what is pulling it round anti-clockwise is that force F. So the force is F, and it's multiplied by the perpendicular distance to the force. Well, that's quite nice because F is acting perpendicularly to the rod. So my perpendicular distance is just 3 meters. So F multiplied by 3. So 8g times 1.5 cos 50 is equal to 3f. So if I just rearrange that, I'm going to get that F is equal to 8g times 1.5 cos 50, all divided by 3. And so we can type that straight into our calculator. Remember, g is equal to 9.8. So I've got 8 multiplied by 9.8 times by 1.5 cos 50, and then divide by 3. And so F is equal to 25.2 newtons, and that's to 3 significant figures. So what we really did there is we used the fact it's at equilibrium. So the clockwise moments equal to the anti-clockwise moments. And remember, we took our moments about that point P. Okay, now that you've finished that, you should hopefully have already done questions 1 to 5 on exercise 4C. Now that we've done this example, you should be able to have a go at all the rest of those questions. So question 6 onwards on exercise 4C, if you have a go at those now, please.